Welcome. I'm your guide, and before we do anything else today, I want you to just take a slow, deliberate breath in with me. Hold it for a second, and exhale smoothly. Settle into whatever space you're in right now. Drop your shoulders away from your ears, soften your gaze, and let the chaos of the outside world completely fade away. You've entered a serene, deep-focused study session. This space is meticulously calibrated to strip away exam anxiety, lower your cognitive load, and bring you into a state of absolute clarity. Today we're going totally minimalist. No mental clutter, no panic, just pure, structured understanding. We're going to calmly and methodically deconstruct Topic 6.3, Continuous Random Variables and Probability Density Functions, or as we usually call them, PDFs. If you're currently preparing for the Cambridge AS and A-Level Mathematics 9709 syllabus, you already know that this specific topic is a massive cornerstone of the curriculum. It's an absolute guarantee. It appears in every single examination series. So, because it's unavoidable, that means it's entirely predictable. Over our time together today, we're going to completely transform what is typically a very stressful mathematical hurdle into a calm, systematic, repeatable recipe for top-band marks. You are entirely capable of mastering this. So, let's ease into this workflow and prepare your mind for total mastery.
Setting our intentions for today, our structural path will flow through 5 distinct phases. First, the Zen of decoding. Second, a collaborative debate. Third, a mindful focus reboot. Fourth, the practice arena. And finally, the systematic recipe recap.
Phase 1. The Zen of decoding, stripping away the noise to isolate exactly what the examiners are assessing.
Whenever you look at a dense, intimidating past paper question, I want you to imagine using a mental highlighter to gently peel back all those filler words. We're looking for the structural skeleton underneath. Listen very closely to this direct transmission from the Cambridge Principal Examiner reports. They stated, candidates consistently confuse key terminology. Always define terms before using them in extended responses. Now, why do you think that happens year after year? It happens because, under the intense pressure of the ticking clock, the human mind instinctively rushes. It seeks shortcuts. Students start blurring the lines between a continuous random variable and a discrete one. They skip over the foundational definitions, and they launch immediately into complex calculus and integration, just hoping the mathematics will somehow speak for itself. Well, I'm here to tell you it won't. The examiner is explicitly warning us here that confusion over basic terminology is the very first and most common barrier to accessing those high-tariff marks. If you don't formally define the parameters of your probability density function before you start manipulating it algebraically, you are essentially building a beautiful, complex house on a foundation of loose sand. True calmness in an examination setting is demonstrated by taking those few extra deliberate seconds to state your terms clearly. It centers you, and it proves to the examiner that you are entirely in control.
To really visualize this, I'm bringing Scholar Alex into our shared mental workspace. Alex is a student whose approach is exceptionally rigorous and highly analytical. When Alex encounters a PDF question, they don't reach for the calculator first. Instead, they meticulously map out the foundational definition step by step. Alex actively writes down the constraints, stating clearly that the function must be greater than or equal to 0 for all valid inputs, and that the total area under the curve, meaning the definite integral across the entire defined domain, must equal exactly 1. By physically writing out these absolute mathematical truths before executing any operations, Alex is doing something incredibly strategic. They are proving to the examiner that they possess a deep understanding of the underlying theoretical architecture of probability. As Alex would tell you, this isn't just about moving algebraic symbols around a page. It is a solid framework resting on causal relationships and pure logic. The Cambridge Assessment Framework heavily prioritizes this kind of analytical depth over superficial memorization. You're never just crunching numbers in a void. You are mathematically reasoning through a continuous spectrum of probability, and acknowledging that spectrum is how you unlock the highest grade bands.
Moving smoothly into Phase 2, the collaborative debate. This is where we bridge the gap between raw mathematical facts and real-world context.
This is where the real magic of intellectual synthesis happens. I want to introduce Scholar Sam into our space to collaborate with Alex. We have two very different minds here. On one side, we have Alex's approach. As we know, it's highly precise, bursting with logical reasoning, and heavy on unshakable mathematical facts. It is structurally sound. On the other side, we have Sam's approach. Sam is an incredibly dynamic thinker. Sam excels at making strong cross-topic connections and adapting to entirely unfamiliar contexts, which Cambridge loves to throw at you. But Sam sometimes moves too fast, resulting in a lack of clear mathematical notation. When they sit down to collaborate on a complex expected value question, a fascinating debate unfolds. Alex confidently argues we have to show flawless, step-by-step integration to secure all the method marks. The calculus is the core. But Sam pushes back, countering with, yes, absolutely, but if we just leave the answer as a raw fraction and don't explicitly write a sentence linking that expected value back to the specific real-world prompt, like the average lifespan of a battery or the waiting time at a clinic, we lose the evaluation marks entirely. And you know what? Sam is completely right about that. The principal examiner reports continually emphasize the candidates who reference cross-topic connections and context achieve significantly higher marks. However, Sam's messy notation is a massive liability. As your guide, my role is to mediate this workflow. I show them both, that while Alex's analytical depth provides the vital engine, it's Sam's ability to evaluate the context that provides the steering wheel. To craft that perfect top-band response, you absolutely must have both. To permanently resolve this kind of structural roadblock, the tension between pure math and contextual evaluation, we need to standardize your process. I'm going to map out the ultimate foolproof deconstruct, solve, evaluate sequence. Think of this as your personal 5-step recipe for absolute exam serenity. Step 1. Deconstruct the question. Calmly highlight the command words. Is it asking you to show that or find? That completely changes your required output. Step 2. Extract relevant data. Pull the specific functions, the limits, and the given variables out of that dense paragraph of text and list them cleanly on the side of your page. Isolate the signal from the noise. Step 3. Select your analytical framework. Ask yourself, are we finding a median here? A variance? Set up the correct algebraic and integral equations before you start solving. Step 4. Execute with clear notation. This is where you channel Alex. Show every single step of your calculus. Do not skip lines. Do not hide your working in your head. Step 5. Present with correct terminology. This is where you channel Sam. Finalize your answer with the appropriate units and write a definitive sentence that links your numerical result directly back to the real-world prompt. If you internalize this specific 5-step sequence and follow it rigidly every single time, you insulate yourself entirely against exam panic. You will literally never sit there staring at a blank page wondering what to do next. You simply take a breath and move to the next logical step.
Now, why is this specific 5-step process so incredibly powerful? Because it maps flawlessly onto the hidden architecture of the examiner's grading rubric. Let's look at the method mark strategy. Cambridge awards your marks progressively across 3 specific domains. The first phase is initiation. The action required here is simply identifying the given information. This satisfies the domain of knowledge and understanding. You literally secure marks just for extracting the correct limits and setting up the basic PDF integral equation correctly. The second phase is processing, where you solve systematically. This targets the application and analysis domain. And here is the absolute secret weapon of the method mark strategy. Even if your nerves get the better of you and you drop a negative sign or make a minor arithmetic error in your final calculation, if your systematic processing steps, your calculus rules, your algebraic expansions are cleanly documented on the page, the examiner can, and very often will, award you substantial method marks. You are being rewarded for your procedural logic, not just your final numerical destination. Finally, we reach the conclusion phase, which requires you to make justified recommendations. This satisfies the highest, most elite domain of evaluation. This is where you prove beyond a shadow of a doubt that you understand what your calculated area or expected value actually means in the context of the messy real world.
Phase 3. The Mindful Focus Reboot. Let's take a deliberate channel pause and a mental reset.
I want you to let go of the mathematics for just a few seconds. Close your eyes if you can. Unclench your jaw. Notice if you're holding any tension in your neck, and just let it melt away. Take a deep, slow breath in through your nose and exhale smoothly through your mouth. As we prepare to craft our final, flawless response structure together, let's make sure your daily study environment is fully optimized. I invite you to subscribe to the channel right now at Ace the Exams. That's at Ace the Exams. And go ahead and enable all notification alerts. Just visualize that clean, minimalist notification bell lighting up on your screen. Whether your current target is building a rock-solid AS-level foundation or securing that absolute top-tier A-level A-star, this channel is your dedicated weekly space for stress-free, deeply structured exam mastery. By subscribing, you are making a conscious, deliberate intention to prioritize calm, methodical learning over frantic, anxiety-driven last-minute cramming. You're choosing structure over chaos. Let's carry this beautifully restored, focused energy forward into the next phase. Phase 4. The Practice Arena. Navigating the examiner's warnings with total precision. Now that our mental focus is restored to a perfect 100%, we are stepping into the practice arena. We're going to apply our highly refined methodology against the most common pitfalls.
I'm going to walk you through the top 3 classic traps directly pulled from the principal examiner reports. These are the exact places where structural discipline typically breaks down under the harsh glare of exam pressure. Trap number 1, using the wrong approach for the wrong context. This incredibly common error happens when a stressed student blindly applies a memorized integration formula without taking 3 seconds to verify if the conditions for a continuous PDF are actually met by the data provided. You have to read the room, so to speak. Trap number 2, forgetting to check format and presentation. Listen to me carefully here. The Cambridge syllabus explicitly dictates that presentation follows strict, established conventions. If you rush and your integral notation is missing the DX, or if your logical flow is chaotic and scattered across the page with no clear progression, you will bleed marks pointlessly. The examiner simply cannot award marks for brilliance that they cannot read or logically follow. Treat your page layout with respect. Trap number 3, providing answers that are not specific to the context given. Let's say you flawlessly execute a complex integration and calculate that the expected value is 4.2. Fantastic. But 4.2 what? Are we talking about hours until a machine breaks down? Millimeters of rainfall? Thousands of dollars in profit? If you provide a naked, isolated number without connecting it firmly back to the specific, real-world context of the random variable in your final sentence, you have failed the evaluation assessment objective. Context is everything.
To really solidify this, let's test your mindful scanning ability with a quick exercise I call the Imperfect Answer Challenge. I want you to imagine looking at a beautifully formatted, mathematically correct paragraph written by a hypothetical student. The calculus is pristine. Not a single negative sign is out of place. The presentation is neat and flowing, but it's fundamentally flawed. It won't get full marks. I'm going to give you a mindful moment to think about this. As a hypothetical 60-second timer slowly counts down in your mind, I want you to scan that imaginary text. Where does the structural discipline break down? You're looking for the transition point between the processing phase, the math, and the conclusion phase, the evaluation. Where exactly does the student fail to provide that crucial evaluative link back to the original prompt? When reviewing your own work, you often have to look deeply for what is missing rather than simply confirming what is already there.
Let's reveal the hidden gap. The problem in our hypothetical perfect answer wasn't the mathematics at all. It was the depth of the analysis. The examiner report clearly dictates that higher-order assessment objectives, for instance, when you are asked to evaluate or compare 2 entirely different probability density functions, demand genuine evaluation, not just observation. A true comparative analysis requires you to actively identify similarities and differences. And crucially, you cannot just make broad statements. These comparisons must be rigidly supported by your mathematical evidence, and they must be linked together using specific comparative connectives. You need to use words like whereas, conversely, similarly, or in direct contrast. You absolutely cannot just state 2 calculated facts side by side and hope the examiner does the comparing for you. You have to do the heavy lifting. You must justify your recommendations and draw explicit logical conclusions about their relative meaning. When you intentionally weave these comparative connectives into your final mathematical conclusions, you are sending a bright, unmistakable signal to the examiner that you are confidently operating at the very highest cognitive domain.
We've reached Phase 5, the systematic recipe recap. Time for the final polish.
Our scholars Alex and Sam have now beautifully synthesized their approaches. They've crafted a perfectly balanced, flawless response. As our deep focus session nears its satisfying conclusion, I want to distill everything we have unpacked today into 3 core focus pillars. Memorize these, and you will never blank on continuous random variables again. Pillar 1, the 3-step question scan for decoding. This is your initiation. Before you ever write a single digit, scan for the specific command word, extract your given parameters, and calmly select your analytical framework. Set the stage. Pillar 2, the marks per minute flow formula for timing. This is about emotional regulation and pacing. Keep a calm, detached awareness of the clock. As a general rule, a 5-mark question deserves approximately 5 to 6 minutes of your absolute focus. If you find yourself bogged down on a single, frustrating integration step for 10 minutes, stop, step back. Rely on your beautifully structured steps to secure the partial method marks, take a breath, and move forward calmly. Do not let one difficult integral derail your flow state. Pillar 3, the final polish review pass for format verification. In the final 2 minutes of your exam, when the adrenaline is fading, scan your paper purely for presentation conventions. Don't redo the math. Just check. Are the units there? Is every DX in place? Is the terminology correct? Is the real-world context explicitly referenced in a concluding sentence? This final systematic polish is very often the exact difference between a high B and a very comfortable commanding A grade. You are now fully armed with the exact mental architecture required to completely dismantle Topic 6.3. But before we part ways, I want you to consider this final thought. If a probability density function represents the absolute mathematical certainty of an event occurring within its specific limits, how might intentionally shifting the limits of your own focus completely redefine your real-world predictions for exam day? Think deeply on that. I want you to leave a comment below right now, officially identifying the specific Cambridge subject, the tier, and the exact target grade you are currently meditating on. Put it out into the world. Make sure you have subscribed to Ace the Exams at @AceTheExams and click that notification bell so you don't miss our future focus deployments. Maintain your deep focus, protect your peace of mind, and trust the systematic architecture you have built today. You're ready for this.